Greetings everybody and welcome back to another exam video. Today we're taking a look at the 2017 Methods Exam 2 Multiple Choice. So let's jump straight into it. Question 1, I feel like we always get these questions as the first one where we have a trig function and find the period and range or something like that. Anyways, how do you find the period? You just take 2 pi and you divide it by 2, so that gives you pi. How do you find the range? Take the mean position, which is -1, add or subtract the amplitude, which is 5, and that gives you -1 minus 5 is -6, -1 plus 5 is 4, so that's going to give you option C. Question 2. Part of the graph of a cubic is shown below. Where is f prime less than 0? So where is the derivative, well, negative? Well, you can clearly see the graph is going down on this interval between the two stationary points, which is between -3 and 5/3, so that's going to be exactly option D. Question 3. A box contains 5 red marbles, so 5 red, and 3 yellow marbles, 3 yellows. There's going to be 8 marbles in total. 2 marbles are drawn at random from the box without replacement. So without replacements means each time you draw a marble, the probability of choosing the next marbles are going to change. So that just screams for tree diagram. So from the tree diagram, we could either have a red with probability 5/8 or a yellow with probability 3/8 initially. Well, if you choose a red, you don't really care about choosing the second red, so we can ignore that branch. We care about choosing the next one to be yellow, and that has a probability. Well, there's going to be 7 marbles remaining because you already removed one. You haven't touched any yellows, so there's still going to be 3 yellows left. And how about from the yellow branch? Well, you only care about picking the red as your next one. How many marbles are remaining? There are 7 marbles remaining. And how many of them are red? Well, there's still going to be 5 red. Okay, so we're just going to multiply across and then add them together. That gives us something like 5 times 3 plus 3 times 5 divided by 7 times 8. And that gives us, that's going to be 30 on the top, I believe, divided by 56. And that's 15/28. So that's going to be option C. Okay, question 4. F and G are functions with these particular values. We want to find f of g of 3. So what is f of g of 3? Well, that's going to be g of 3, first of all, is going to be, just find it, it's going to be 2. And what's f of 2? It's going to be 5. So therefore, we have option E. Question 5, the 95% confidence interval for the proportion of tickets, blah, 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 is this guy over here. We want to find the sample proportion. Now, the nice thing about sample proportion is that it's always halfway between the endpoints of your confidence interval. So if this is a confidence interval, here's your sample proportion right in the middle. That's your p-hat. So we just need to calculate the mean of those two numbers. So let's do that. 0.039 plus 0.121 and divide that by 2. That gives us the answer. So that's going to be option A. Sometimes you might be asked for like what's the standard deviation, in which case the calculation will be slightly more involved. Luckily though, if you do have the programs, link in the description if you're interested. You can go to method stats, go down to solve confidence, plug in those endpoints there. So solve confidence, how does that work? I've got to show you. Solve confidence works by putting in the upper and lower bounds of your confidence interval and then some piece of data. So what does that mean over there? You put in the endpoints, 0.121, and then you put in something that your question has, for example, that 95% confidence level there. And what is that third argument? Well, it was the confidence level, so we select 2, because the CAS needs to know what that 95 is. So it's the confidence level, and then it gives you all sorts of things over here. So we were interested in the sample proportion. That was a nice and easy calculation, but you can also find the standard deviation and the number of trials as well. It's quite a handy program to have for these sorts of questions. All right, question number 6. Part of the graph of f is shown below. The same scale has been used on both axes. The corresponding part of the graph of the inverse function, f inverse, is best represented by, basically, just imagine you reflect the sky across this line y equals x. So you could roughly imagine what it will look like. You'll have some branch going off, let's see, over here roughly, and then maybe something that goes down like that. And if you just look at all these pictures here, well, which one matches? It's going to be option C. Okay, question 7. The equation p minus 1 x squared plus 4x equals 5 minus p has no real roots when. So this is a quadratic. This equation has no real roots when the discriminant is less than 0. So before we use the discriminant, we do need to move everything on one side, because to use the discriminants, you need the quadratic equal to 0. So p minus 1 x squared plus 4x minus 5 plus p equals 0. Now you just have to identify what your constants are. So this is the b constant. This whole thing here is the c constant, and this whole thing here is the a constant. So the discriminant formula, why am I using red? Discriminant is b squared minus 4ac. B squared is 16 minus 4. A is p minus 1. C is minus 5 plus p equals 0. Let's simplify this in the CAS because it can't be stuffed expanding it out by hand. So 16, and then we have 4 p minus 1, and then we have a minus 5 and a plus p, and it gives us this equation over here. Okay, we can divide it by 4, no problem. It's a positive number. Just make sure if you're dividing it by a positive number, because what we want to do, I don't know why I set that equal to 0 there. What we want to do is we want to solve where the discriminant is less than 0. So this means that if we take this guy over here, that's minus p squared minus 6p plus 1. This guy is less than 0. We have a negative sign out here, so let's bring it over. And if you divide by negative, well, just remember to flip the sign. So this is greater than 0 now. And does that match any of the options? It does indeed with option B. Okay. Question 8. We have this equation that x is equal to. So we can just solve this on the CAS, I believe. Just type it in. Maybe it won't work because we're going to have a log base a, which I don't think the CAS really likes. Anyways, we can still try it. Solve y equals a to the, and then it was b minus 4x. So b minus 4x, and then plus 2, and we want to solve this for x. And maybe we'll just add the condition a is greater than 0 just to be safe. And yeah, I don't think the CAS liked that at all. Maybe you can simplify it a little bit, but yeah, maybe we'll just do it by hand because that's not going to work out too well. So to do this by hand, we'll subtract 2 on both sides, and that's a to the b minus 4x. And we'll take the log base a on both sides. Log base a of y minus 2 is equal to b minus 4x. We'll bring the 4x over and then this logarithm over, and that gives us 4x equals b minus log a y minus 2. And finally, we'll divide by 4. So that's going to give us 1/4 b minus log a y minus 2. And let's match answers. It looks like it's just going to be option A. Okay, question 9. The average rate of change of the function with this rule over the interval 1 to a is 8. We want to find the value of a. Let's just apply the average rate of change commands. You can plug it into that formula into the CAS if you want to, if you don't have the programs, but I'll just use average change. We'll do x squared minus 2x, x, comma, we're going from 1 to a. That gives us a minus 1. We want a minus 1 to be equal to 8, so that means a must be equal to 9. If it was something more complicated, you would use like solve, you'll take this guy and set it equal to 8, comma a, and yeah, the answer is indeed a equals 9. Alright, question 10, we have a transformation with a specific rule over here, which maps the graph of y equals 3 sine blah 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 onto the graph of. So we're applying this transformation to this graph. It's very important to know which way the transformation is going. We're applying the transformation to this graph. Luckily, there's a nice program that does that called transform, and I'm supposed to be writing a bunch of other transform programs. At the moment, there's this one transform program which is transform your function, but how does this guy work? It's 3 sine of 2 and then x plus pi on 4, and then we'll do comma x as the variable, and then we'll give a list of transformations. That's just going to be 2x and then a third y. 2x comma a third times y. That gives us just cosine. That's going to be D. If you want to do this by hand, what you have to do is you have to write x prime equals 2x, y prime equals a third of y. You rearrange these guys so you can plug x and y back into this equation. So that gives you x equals x prime on 2, y equals y prime, actually 3y prime, I believe. So if you plug that in, you're going to get 3y prime equals sine of 2, and then x is x prime on 2 plus pi on 4, and then y prime is equal to, well, I got a 3 there. You can cancel the 3's and you'll just get sine of the 2. Actually, we can cancel the 2's there, can't we? So that's going to be x prime plus pi on 2, I believe. So you can get rid of the primes now because we're done with them. Sine of x plus pi on 2, that's translating your sine graph. So here's my sine graph. You're translating it to the left by pi on 2, but this turning point is going to become the y-intercept, so that just gives you a cos graph. So y equals cos of x, which is the answer. Question 11. We have a cubic, it looks like, has a local maximum at -1 and local minimum at 3. Find the values of a and b. So we have two unknowns, we just need to cook up two equations and solve it on the CAS. First of all, I'll define f of x to be equal to x cubed plus a times x squared, and then plus b times x. I'll also define the derivative because we want to refer to the fact that these guys are stationary points, so we need to use the derivative. df of x equals, I'll do shift minus for the derivative of x, of f of x. Okay, and I'm going to solve now the derivative. Now the derivative at -1 and 3 has to be equal to 0. So df of -1 equals 0 and df of 3 equals 0. And I'll solve it with respect to a and b. That gives us -3 and -9, which is option D. Question 12. The sum of the solutions to sine 2x equals √3 on 2 over this interval is -pi. We want to find the value of D. Okay, so to do this one over here, what you could just try is you can just do solve, and then we have sine of 2x equals √3 on 2, and we solve for x, and we'll put the restriction, so that's minus pi, less than x, less than, we'll just take the biggest one of these values just so we can get all the possible solutions. And well, we have this guy over here, then you can just go through manually trial and error and try to sum them up, make it equal to -pi. But that's a little bit inefficient, I believe, because what you can do is you can use the zeros commands. So to use the zeros command, you need to rewrite this equation in terms of something equals 0. In particular, we could write it as sine of 2x minus √3 on 2 equals 0. And the nice thing about doing that is you can use the zeros commands now. So this is sine of 2x minus √3 on 2. And then you can just put comma x. Notice you don't need to put equals 0 because this command is going to find the zeros of this equation anyways. And we'll also put that restriction, so minus pi is less than x, less than 3 pi on 2. Actually, that's wrong. I just realized you need equal to. Oh dear. So this is equal to. Be careful with that. Okay, so this is what we get if we use the zeros commands. It gives us the answer as a nice list. Now, why do I prefer list over just listing out the solutions over here? It's because you can use the sum command, and if you put a list inside of the sum command, it, well, calculates the sum of everything. In fact, because this whole expression here gives us a list, we can just chuck that whole thing inside of the sum command. Something like this, click enter, gives us the answer. So all you have to do now is just change this upper bound here of the domain, this d, until we get to the desired sum, which is -pi. So this d, well, we tried 3 pi on 2, which didn't work. Let's try 7 pi on 6 now. 7 pi on 6, and it gives us pi on 6, not quite there. Let's try 3 pi on 4. It's 3 pi on 4, and that gives us -pi. So we'll go with C as the answer. All right. Question 13. This one's outside the study design, but we might as well go through it anyways. So which one of the following statements about h is not true? So what I'll do is I'll define h of x to be equal to 1 over x minus 1, I believe. And we'll just run through all of these and type it in, I guess. So h of x, h of -x. And instead of having to evaluate the left-hand side and matching it with the right-hand side, you can just move everything on the right-hand side over to the left-hand side and see if it equals to 0. So in this case, I'll do plus h of x squared, and that gives us 0. And this is not true over here, so A wouldn't be an option. Let's try B. H of x plus h of negative x, I think it was. Then minus 2h of x squared. And that also gives us 0. Let's try C. H of x minus h of 0. And we have a minus x times h of x. That also gives us 0. Let's do D. H of x and then minus h of negative x. Then we have a minus 2x times h of x squared. That also gives us 0. So hopefully it's E. We'll try that. H of x, but the whole thing squared. And we'll subtract h of x squared. That gives us something that's non-zero. So it's option E. I had to put at the end. So we had to go through all of that. Okay, question 14. Random variable x has the following distribution where p is between 0 and the third. Find the variance. So you could just do it manually. Hopefully you know the formula for variance. It's e of x squared minus e of x, but the whole thing squared. Or you could use discrete info, which is in the probability library, discrete info, and you put in the list of x values, -1, 0, 1, and then the corresponding list of probabilities, which is p. That's going to be a 2p, and finally a 1 minus 3p. And there's your variance. It doesn't seem to match any of those answers. Maybe we need to expand it a little bit. So I'll expand. I'll grab this guy over here. And it's 6p minus 16p squared, so it's going to be D. Alright, question 15. We have a rectangle. Okay, and we want to find the maximum area of this rectangle. It's inscribed inside of this graph minus x cubed plus 8. So how can we do that? Well, first of all, what's the area of this rectangle? I need to select a variable to, well, differentiate with respect to. So let's choose u, because this area of the rectangle is precisely u times v. So this is going to be u times v, but here I don't want two variables, I only want one. We know what v is. It's precisely minus u cubed plus 8, because we just plug a u into this formula up here. Okay, and we just need to, well, find the maximum area of this guy. We can use the analyze program for that. So let's go to analyze. We can use analyze with the domain as well, because we know what the domain for u is. It has to be between 0 and 2. So we'll do u times minus u cubed and then plus 8. And then we'll go with respect to u and use between 0 and 2. And we found the local max. It's 6 cube root of 2. So it's option B. Question 16. For random cities, where did I get cities from? For random samples of 5 Australians, p hat is the random variable that represents the proportion who live in a capital city. Probability of p hat equals 0 is 1 over 243, and we want to find this probability. So first of all, what you can do, p hat, if you're working with, we're assuming this is a large population, and we're selecting a small sample, which means you can always rewrite p hat into a binomial random variable in the following way. You just do p hat times n is equal to x. Or if it's more intuitive this way, p hat is equal to x over n, where x counts the number of successes in your trials. So how to convert this probability over to x? Well, you're just going to multiply everything by n, but 0 times n is precisely equal to 0. So this is the same thing as the probability that x equals 0. Now what exactly is x? X is a binomial random variable with 5 trials and probability of success p, which we don't know. Okay, so what's the probability that x equals 0? It's n choose, which is 5, choose a 0 in this case, which is 1. And then you do p raised to the 0, 1 minus p raised to 5 minus 0, which is 5. And we want this guy to be equal to 1 over 243. Okay, p to the 0 is 1. So we're just left to solve this equation here for p, which shouldn't be too bad to do. So I'll solve 1 minus p raised to the 5 equals 1 divided by 243, and I'll solve with respect to p. P is 2/3. So p is 2/3. Okay, so now we have all the parameters for this binomial, so we can evaluate this probability. Now, what is this probability in terms of x's? Well, just multiply everything through by n, which is 5 in this case. So x is greater than, what's 5 times 0.6? It is exactly 3. So we want x greater than 3, or equivalently, this is x greater than or equal to 4. So we need to calculate this probability now. Not too tricky to do. Just go to binom CDF, and we'll go to number of trials. That's going to be 5. Probability of success is it's 2/3. Lower bounds is 4, upper bounds is 5, and it's going to be 0.46 or something. So it's going to be option C. All right, question 17. What do we have? The graph of a function f, where f of negative x is f of x. This just means that f is an even function, so it's metric across the y-axis. That's very important. The graph has x-intercepts at a0 to a, b, c, d only. The area bounded by the curve in the x-axis on the interval a to d. So that's exactly this area over here. So we're going to go from a to b, b to c down here, then c to d. First of all, it's not going to be a, because if you just integrate straight from a to d, you're going to get this negative area here, which is not going to give you the actual bounded area. For b, we're going from a to b of f of x, a good sign. So if I was splitting things up, then we're subtracting the integral from c to b, which is going backwards, which is slightly concerning because this area over here is already negative. If you're working with a negative area, you either reverse the bounds or you put a negative sign in front of the integral, not both. So it's not going to be b because that doesn't calculate that proper area there. For c, we have 2 times the integral from a to b. Okay, so it's accounting for this other area over here. Then the integral from b to c of f of x dx. That's also wrong because, again, this area is underneath the x-axis. So you either need to reverse the bounds or introduce a negative in front of that integral to counteract the negative area, none of which are happening. So that second integral wouldn't be correct. For d, integral from a to b of f of x, and we're doing twice of that. So again, it's these two humps over here. Then we're subtracting twice the integral from b to b plus c. Now, what exactly is b plus c? Notice that this function is symmetric, which means b is going to be precisely negative c, which means b plus c is equal to 0. And because b plus c equals 0, we can just replace this guy with a 0 over here. So we're integrating from b to 0. So b to 0, of f of x. And we have a negative out over here because the area is underneath the x-axis. And we're doubling it because it was symmetric. So that's one integral over there that's calculating the area of this part. We need to double it to get the whole area from b to c. So this is going to be the correct one over here. And just to make sure, we can check the e's wrong because a to b of f of x, that's fine. And then plus a c to b of f of x. Plus c to b. Okay, so that second integral is right there because the area is below the x-axis. And the bounds are reversed to counteract that, which is good. But then how about the integral from d to c? Well, that's a bit funny because now we're reversing the bounds when there's no need to. We can just go c to d. If you do the reverse bounds over here, then you give, you pick up a negative sign. So e is going to be wrong. Okay, question 8. Let x be a discrete random variable with binomial distribution NP. The mean and standard deviation of the distribution are equal. So what's the mean? It's NP. What's the standard deviation? It's square root of NP 1 minus P. These two guys are equal, so let's see if we can do something with this. This is the probability, and we know that P is less than 0.01. And we want to find the smallest number of trials at n for which this is the case. Okay, so first of all, maybe my first thought is to cancel NP on both sides somehow, or maybe it's better to square things just to get rid of that square root. So n squared p squared is equal to np and then 1 minus p. And we can cancel the n and the p on both sides because both of them are non-zero, which leaves us with np equals 1 minus p. Okay. Now what can we do with this? Well, we can rewrite this for n, because we're trying to find n. N is equal to 1 minus p over p. Okay, so what I managed to do is I managed to get an expression for n in terms of p. Now I want to use this bounds here somehow to get an expression for n. So let's actually start with this inequality here and try to work our way to this equation. What I'm going to do first of all is just divide the top and the bottom by p, just so I have p in one spot. It's easier to work with. So that gives us just, yeah, if you divide the top and the bottom by p, that's just 1 over p minus 1. Okay, so from this equation here, you can reciprocate both sides. 1 over p is greater than or equal to 1 over 0.01, which is 100. And we need to subtract 1. 1 over p less than or equal to 100 minus 1, which is 99. Sorry, minus 1 there. And that's equal to n. So n is greater than or equal to 99. Therefore, the smallest number of trials you need is precisely 99. 2 more questions to go. Question 19. A probability density function is given by the following. What is the value of k? Well, probability density function must integrate to 1. So what we can do on the CAS is solve the integral of this guy equals to 1. So we solve the integral from, what is it, k up to k plus 1 of the density, which is cosine of x and plus 1. Now technically it's negative infinity to infinity, but because it's 0 everywhere else, we can just chop it off on this interval. We integrate with respect to x, and we set this equal to 1, and we're trying to find the value of k for which this is the case. We get a general solution, as expected, because we're working with some trig thing. So let's impose this condition that k is between 0 and 2. And we get pi minus 1 on 2. So that is option D. And the final question, question 20. The graphs of f and g are shown below. The graphs intersect at B. Find the ratio of the shaded area to the area of the triangle. Okay, so let's just define the functions first of all. Define f of x equals, f of x was a cosgraph, just a plain old cosgraph, and g was, what was g? G was a sine graph, wasn't it, with a root 3 out the front. G equals square root of 3 sine of x. Okay, and we want to find this intersection B here. Let's do that. It shouldn't be too tricky to do. You can just use the intersect program, or intersect with a D. We'll do f of x, f of x, g of x, comma x, and the bounds are 0 to pi on 2. And that gives us this point over here. So we know what a B is. Now what do we want to do? We want to find the ratio of the area shaded to the integral to the area of the triangle OAB. Let's try to find the area of the triangle first, because that's a bit easier to do. Area is just half base times height. The base is pi and 2. The height is going to be the y coordinate of B, which is this guy over here. So let's compute that. We'll define it as tri, why not? Tri is 1/2 times the base, which is pi on 2, times the height, which is this guy right over here. And we can get an expression for that if we want to. It's pi root 3 on 8. I don't know why I defined that, anyways. Okay, now let's do the integral area, so the actual area. So we can split this up across this intersection points here, because the first part is going to go from 0 to b, but we're integrating the function sine, which is g. So the integral from 0 up to, that's going to be, what was that x coordinate of the intersection point? So it was pi on 6. So go from 0 to pi on 6 of g of x dx. And then we'll also add the integral, and now we're going to go from pi on 6 up to pi on 2. And we're going to integrate f of x this time. And let's see what that gives us. It gives us root 3 minus 1. Okay, so root 3 minus 1 was the area of the shaded region. Root 3 minus 1. The area of the triangle OAB, it was pi root 3 on 8. So just looking at the answers, it's got to be B. Yeah, that should be right over there. Yeah, not too bad actually. It took a bit shorter for me to do than expected. But yeah, that's all for this exam. Hopefully you guys found it useful, and up until the next one, hope you guys have a wonderful day, and I'll see everyone in the next video. Bye bye.